Welcome to part 2 of 2 videos about my new dust extraction system. In the first video I talked about why I wanted to upgrade from my 2 shop vacs in the workshop, and in this video I'll talk about what I've upgraded to and how I did the upgrade. So I'll start with the heart of the system, the dust extractor itself. This is the pneumatic NVD 750 from Axminster Tools. Axminster are not a sponsor, I paid for this with my own money, and it was around £570, which is about $770. This is the model with 2 1200 watt motors. Axminster do sell a cheaper model, which is the NV 750, which has a single 1200 watt motor, but I wanted the extra suction that this machine should provide. So this machine on its own is an L class extractor, and in order to upgrade it to an M class extractor, capable of dealing with the smallest micron particles of dust, which are produced by things like sanding and cutting MDF, I bought the additional HEPA module for this machine. This was an additional £334, which is about $450. This module fits directly onto the extractor with some mounting clips. So in total this machine came to just over £900, which is about $1,200. And that's much more than I had originally planned to spend, but I chose this model for a few good reasons. Firstly, it's an M-class machine, which I've already explained. Secondly, its size. It's a relatively compact machine and it fits really nicely in my newly built shed extension. And thirdly, it's very quiet. And the best way I can demonstrate how quiet this machine is to show you this footage of my cat, who is very scared of any vacuum I've ever used. After unboxing the machine, I was about to turn it on for the first time and my cat happened to be in the room, and this is how he responded. The extractor also comes with a wheelbase, which I don't really have any use for, so I unclipped that part. So my first impressions of this machine are excellent. The build quality is fantastic, the suction is incredibly powerful, it's really quiet, and it's an M-class extractor. It's far better than any vacuum I've ever used, but it ought to be, because this is 6 times more expensive than my Fox shop vac and 18 times more expensive than my Titan shop vac. So the next part of my system is this, my homemade cyclone dust separator. I won't go into too much detail about what this thing does because there's plenty of information out there on the internet if you want to find it, but just to offer a very quick explanation, this sits in between my dust extractor and the air that's being sucked in. This piece up here creates a vortex which separates the majority of dust particles into this box before they reach the extractor. And that's good for a few reasons, but the main reason is that it keeps the filter in my extractor cleaner for much longer, so less maintenance is needed and less cleaning to be done. And it also makes for a more convenient way of emptying the dust because I can just empty this box rather than going into the extractor itself. This part here is the cyclone itself, and I bought that on Amazon for around £22. I'll leave a link to that in the description box below. And below that, this is a 70 litre airtight plastic container, which I also bought on Amazon, and I'll provide a link to below. This was around £32. Quite expensive, but for me it was perfect because I didn't have much height to play with in the shed extension. If you're looking for something similar but you have more height to play with, a good alternative would be this 60 litre airtight container, which I'll also provide a link to. This is actually the one I ordered originally and intended to use, but unfortunately it was too high to fit in my shed extension, so I had to send it back for a refund. Here's what I did to fit the cyclone to the lid of the box. The cyclone came with a cutting template sticker, so I put that onto the lid. The main hole requires a 75mm hole saw, and I didn't have one that size, so I first drilled a clearance hole and then used a hacksaw blade to cut the hole. This worked surprisingly well.
Like a glove.
Then I drilled pilot holes for the screws and removed the template. I added some sealant to the bottom of the cyclone, and then from the underside of the lid added the screws and washers. I then added some more sealant around the bottom just to make sure it was airtight. While I'm at the extension, there's just one more thing to explain, and that is why I've had these fans installed. This one blows fresh air into the extension, and the reason for that is firstly to help the dust extractor not to overheat, but also because I'm storing my air compressor in here too, which obviously also needs a clean supply of air. And this intake valve on the compressor here is facing up towards the fan. This compressor is new to me too, so I got rid of my old compressor and got this one instead because this one is extremely quiet. On the other side of the extension there is another fan, and this one will blow air out of the extension. And the logic behind adding this fan was primarily just to get rid of the air that's exhausted by the dust extractor. Now this may or may not be necessary. To be honest, I don't really know about this sort of stuff. Hopefully someone in the comment section will point out what I've done right or wrong here. These are the fans and grills which I bought from a shop called Maplin in the UK, but you can get these cheaper on Amazon. Links in the description box below. To fit the fans, I first traced around the grills, drilled a clearance hole, and then cut out the circle with my jigsaw. The grill could then be fitted with bolts through the wood cladding, and then on the inside the fan could be secured onto those bolts with some nuts. The power to both the fans and my air compressor is controlled by this switch in the workshop. I got my electrician to handle all of the wiring for this. The next job was to get started on the ducting, and first I needed to connect up the extractor to the cyclone separator. I bought a vacuum hose on Amazon which came with 2 adapters. I'll link to this in the description box below, and one of those adapters was perfect for connecting up the hose to the cyclone. This hose is the threaded type, so I could just cut it to the length that I wanted, twist on the cuff that came with the adapters onto the pipe, and then push on the screw-on adapter that fitted onto the extraction machine. I could then screw on the adapter that came with the hose, and this pushed snugly onto the top of the cyclone fitting, which was an unusual size, as they all seem to be. I really needed 2 of these adapters so that I could connect up the second port on the cyclone. But for the time being I just used another adapter that I had kicking around that was almost the right size and wrapped around some gaffer tape until it was a good fit. I'll probably replace this later as soon as I find one that fits. Next I needed to install the pipes to connect up each of my workshop machines to this extraction system, and I knew that I needed to keep all of the pipe runs as short as possible in order to maximise the suction to each machine. The best option that I had was to mount the pipes to the ceiling of my workshop. It would have been even better if I could mount the pipes in between the ceiling and the roof. However, my roof rafters run perpendicular to where the pipes will run, so that wasn't an option. Next I needed to get the hose in my shed extension connected up to pipework in my workshop. And the pipe I chose for this is 40mm PVC waste pipe. And I also bought a bunch of these push fit fittings to connect up all of the pipework. I got the idea for this from Matt over at the Happy Wife Happy Life channel, and I thought it was a really clever idea because the pipe is relatively small and unobstructive, and if you've got a small workshop like we have, then it's probably the best option. I got the pipe and all of the fittings from Screwfix here in the UK, and it's inexpensive, so that's another reason why it's a good option. I used a long drill bit to drill a pilot hole from the shed extension all the way through the wall into the workshop, and then came back with a 40mm hole saw. Then I realised I was trying to drill through the workshop frame, which you can see here, so I abandoned that and had to drill another hole below it. I could then drill through from the inside of the workshop and insert a length of the PVC pipe through the wall. I had another hose fitting which seemed to connect really nicely to one of these 90-degree pipe fittings, and I tested that just by blowing through it and blocking the air with my hand. And it seemed good and airtight, so I threaded that onto the hose and connected the 90-degree angle up to the pipe through the wall. Then I could connect up more of the push fit fittings to the pipe leading to each of my machines, and I used these waste pipe clips to secure everything. Where the pipe enters my shop, I needed a T-fitting in order to split the pipe in 2 different directions, and because of that fitting the pipe was offset from the wall. So I made a simple storage box thing out of some scrap OSB, and that was mounted to the wall, and that gave me something to attach the pipe fittings to. Later on I gave that a coat of white paint to make it blend in with the wall. The most difficult machine to get the ducting to was my miter saw, and that's because the miter saw has a hood around it. It was a tight space, and I also needed to ensure that the miter saw could still pivot and rotate without that pipe getting in the way. I first drilled a pilot hole from the top down using a right angle chuck attachment in my drill, and then drilled up from below with a 40mm hole saw, and then I could add the pipe and blast gate, which I'll talk about next. I'd need a blast gate at each of the inlets in my workshop in order to control where the suction is going to. I used some offcuts of 6mm plywood to make mine. I first cut some pieces to about 11cm square on the table saw. Then I ripped some thin strips about 15mm wide. I offered them up to opposing edges of the 11cm squares and measured the distance between them, and that was around 71mm. So I cut some more strips at 71mm. I glued and clamped the thin strips onto each side, sandwiched in the middle of another of the square pieces, and then inserted one of the 71mm wide strips, making sure it was a snug fit between them. And then I removed that piece and left it to dry. I later added some small screws just for extra reinforcement. So this is what I had so far. Then I added some more thin strips to each end of the 71mm wide strip of plywood to act as stops for the gate. I soon ran out of spring clamps as I was making the blast gates, so I used some bulldog clips instead. A couple of the gates came out really tight, so I added some candle wax to the inside, and that helped them to open and close more easily. I cleaned up the edges of the gates with a block plane. Then I found the centre of the square and drilled through all 3 layers of the ply at the drill press with my 40mm Forstner bit. And that made the gates open and close. Next, with the gate in the closed position, I could then add the pipe to one side of the gate, and this was quite a tight fit, so I used a hammer to persuade them in. I then used some sealant to attach the pipe and make sure that it was airtight. I could then do the same on the other side of the gate, and then they were ready to connect up to the main pipework in my workshop. Next, I needed to connect up each of my machines to the pipes with the blast gates installed, and for this I'd use more of the threaded vacuum hose which I bought on Amazon. The best solution I found for connecting up the threaded vacuum hose to the 40mm waste pipe was these fittings. I also got these on Amazon, and I'll leave links in the description box below. These come in 3 pieces. The first part pushes on over the threads, the second part twists onto the threads, and the third piece slips over the cuff and clicks into the first piece. And this attachment just happened to fit really nicely inside the 40mm waste pipe. Next, I needed to hook up the other end of the vacuum hose to each of my machines, and fortunately I already had the adapters for most of this from my old dust collection system. This part can be a bit of a nightmare because the dust ports on machines just seem to vary so much with no consistency at all. I needed to move 1 or 2 of my machines around in order to get the ones that needed dust extraction closer to the dust extractor itself. I moved my belt and disc sander to where my pillar drill and bench grinder used to be, and vice versa. Just to demonstrate how the new system will work, when I come into the workshop I will first turn the lights on, and then I'll turn the power to the air compressor and the fans on. In total I've got 5 gates. The first one is connected up to my belt and disc sander. The second one is connected up to my bandsaw, and you'll see here that the hose is rather long, and that's because I can remove it from the bandsaw and then hoover up my worktop whenever I need to. Then the pipes go over to my miter station, and you can see the gate for that one on top of the hood. So coming back on ourselves, we then go along the ceiling, and up here we have 2 gates. The The first one is connected to the table saw, and the second one behind that is connected to a hose which is currently suspended from a hook on the ceiling using some cable ties just to keep it out of the way. And this one I will use for cleaning up the surfaces of my table saw and workbench. This hose will also be used for extracting the dust from power tools at my workbench, such as my random orbit sander and my circular saw. So you're probably wondering by now how I turn the extractor on and off. That's done via this remote control. And I'm going to keep that hooked onto my trousers, so wherever I go, I can power it on and off. I'd love to be able to explain how the electrical wiring was done in order to get this remote control system to work, but unfortunately I have no idea. Electrics isn't my thing. I asked my electrician to set it up the way I wanted it, and that's what he did. And I think it's all contained within this box. You might also be wondering how good the suction is, and I'll demonstrate that using this hose, as this is the longest pipe run. So first I just need to open the gate, and then I can power on the extractor. Hopefully you can see from that the suction is actually surprisingly good. It's not as strong as it is at the machine, but it's certainly strong enough to pick up chips and dust, and also to pull my face around. Now I want to use the table saw, so I'll close that gate and open this one. So here's a quick sound test. I'll first turn the power on to the air compressor and the fans. The air compressor is currently empty, so that will fire up. So hopefully to demonstrate how quiet the new air compressor is, you can hear me talking at a normal volume over that. Next I'll turn on the extractor while the air compressor is still running. And now I'll shut the doors. Now let's see how effective the cyclone is. Quite a lot of dust in there. And now I'll check the extractor. It's a little bit, but not too much. So that tells me that the cyclone is pretty effective. This was a big project and a very expensive one too, but I think it'll be a really good workshop upgrade for the future. I'm very happy with the extractor. The cyclone seems to be performing pretty well, and the ducting and pipe work is pretty good too, so I don't think there's too much that I would do differently if I were to do this project again. The main challenge for me is getting used to opening and closing blast gates, and also turning the extractor on via a remote control, because that's not something I've done for the past 3 years in the workshop, so I just need to get used to that. I'll leave it there because this is probably a very long video already. Thanks for watching.